Hello, welcome to my channel Ganitha Vahini. I am HarshaVardhana. Hello everyone, welcome from the previous session. In this session, we are now going to see some of the problems and the related theorems about combination. Here the one problem said that in a party of 10 people, each person shakes with every other person. How many possible combinations of handshakes can be made? Here the solution. Each handshakes corresponds to a unique pair of person. Also note that the order of two people in pair does not matter. For example, if x and y are two people, then xy and yx won't be counted separately. Only their pair x, y will be counted. Here we consider the combination of any two people who shake their hand. Thus, we need to find number of ways in which two people can be selected out of 10. Clearly, the answer is 10C2. That is 10 factorial over 2 factorial into 10 minus 2 factorial. That is equal to 10 factorial by 2 factorial into 8 factorial. Solving on this, we get 45. We move to the next question. How many diagonals are there in a polygon with n sides? Use the concept of combination to solve this. For this solution we have, if we select two vertices of the polygon and join them, we will get either a diagonal or a side of polygon. Here we can use the concept of combinations. The number of ways of selecting two vertices out of n is nc2, that is equal to n into n minus 1 by 2. Out of these selection, n corresponds to the side of polygon. Thus the number of diagonal is n into n minus 1 by 2 minus n, that is equal to n into n minus 3 by 2. Therefore the number of diagonals are n into n minus 3 by 2. Here we move to the theorem, that is theorem 1. The first theorem states that the relation between permutations and combinations of n objects taken r at a time is npr is equal to ncr into r factorial. For this solution, suppose there are n objects and we have r places to be filled by taking r objects at a time. Therefore, the number of permutations is npr. The process is of two events. The first event is selecting r objects from the given n objects, and the second event is arranging these r objects in r places. The first event of selecting r objects can be achieved in ncr ways. First event of selecting r objects can be achieved in ncr ways, and the second event of arranging r items in r places can be done in r factorial ways. Using the multiplication rule, the whole process is equal to ncr into r factorial, that is npr is equal to ncr into r factorial. This is the proof. For theorem 2, we have ncr plus ncr minus 1 is equal to n plus 1 cr. For this we have LHS n factorial over n minus r factorial into r factorial plus n factorial over n minus r plus 1 factorial into r minus 1 factorial. That is n minus r factorial into r minus 1 factorial plus n factorial by n minus r plus 1 factorial into n minus r factorial into r minus 1 factorial. Then n factorial by n minus r factorial into r minus 1 factorial into 1 by r plus 1 by plus 1 by n minus r plus 1, that is equal to n factorial over n minus r factorial into r minus 1 factorial into n minus r plus 1 plus r by r into n minus r plus 1. Therefore, n factorial over n minus r factorial into r minus 1 factorial into n plus 1 by r into n minus r plus 1, that is equal to n plus 1 into n factorial by r into r minus 1 factorial into n minus r plus 1 into n minus r factorial, that is equal to n plus 1 factorial by r factorial into n minus r plus 1 factorial. Therefore, that is equal to n plus 1 r factorial into n plus 1 minus r factorial. The final answer is n plus 1 C r. In theorem third, we have NCA is equal to NCB is equal to NCB. Then A is equal to B or N is equal to A plus B. Given NCA is equal to NCB. Suppose A is not equal to B. Let us consider A is less than B. That implies n factorial by n minus a factorial into a factorial is equal to n factorial over n minus b factorial into b factorial. That implies n minus a factorial into a factorial is equal to n minus b factorial into b factorial. That implies n minus a into n minus a minus 1 into n minus a minus 2 so on to n minus b plus 1 into n minus b factorial into a factorial into n minus b factorial into b minus 1 into b minus 2 so on to 1. The first term on the left hand side is expanded using the fact a is less than b, and the second term on the right side is also expanded in a similar way. That implies n minus a into n minus a minus 1 into n minus a minus 2 so on to n minus b plus 1 is equal to b into b minus 1 into b minus 2 so on to a plus 1. Since the either side of the product is a b minus a consecutive positive integer, we have n minus a is equal to b. Therefore, n minus a equal to b. That implies n is equal to a plus b. NC n minus r is equal to NCR. In this, we take LHS. N factorial over n minus n plus r factorial into n minus r factorial. That is equal to n factorial by r factorial into n minus r factorial, that is equal to NCR. These are all the theorems on combinations. With this, I will conclude this session. Those who have any doubt or clarification in this chapter or in these videos, please reach it out. And those who didn't see the video or listen the video, I will put the link in the description box. You can go to the description box and click and listen the video. Those who like the video, please like it, share it and subscribe it. And if you have any doubts, put comments on the comment box. I will see the comment and rectify your comments.